In this part 1 of design and documentation of complex test system setups, we'll introduce concepts and tools. My name is Heussen. I'm a senior researcher at the Technical University of Denmark, and I've contributed to the HDD development in AeroGrid. The motivation: when we want to test smart grid solutions, we have a rather complex technology that involves different types of automation, control, involves different technologies such as the distributed energy resources, storages, PV plants in this context. We also have an infrastructure, the power distribution network, and all of these technologies are interacting. So if we want to test in this setting, we need to identify which part of all of this we're going to test. We also have to consider that there is a real-time feedback interactions across several timescales, and also complex cyber-physical interactions can appear between, for example, controllers on the DR level and controllers at the distribution network. So even if the technology is understood, how can we approach the validation of a smart grid solution? We make it more concrete. We also have the smart grid testing problem in the lab, where we can imagine the technology that was outlined before, more concretely here, as a combination of a coordinated control system with an online tap changing control transformer that is coordinating different energy resources such as PV inverters or electric vehicles. And of course, there should be electrical distribution network in the lab. We also have to consider that there's communication. And together, we want to evaluate if now this control system enables the extension of the hosting capacity of the distribution network. So all of these technologies interacting is clear. So if the proposed solution is clear, how do we test it? Well, what we would like to have is a test description that is understood by technical terms. The test description should inform us what we're testing for. Are we testing interoperability between devices? Are we validating the function of the device? Are we assessing the control performance? Which of the devices are we testing? Which of the subsystems? And what are the conditions? And do we need a full-scale lab test? Is a simulation sufficient, or anything in between? To scope this type of testing problem more clearly, we have developed the holistic test description method. And I would like to contextualize this based on this principal use case of a smart grid, voltage control, or active distribution network. So if we want to describe this technology, already we have some available standards and templates. We can first describe the system configuration. That means we can describe the power distribution grid and its topology using, for example, the common information model. We can describe interconnections between the automation equipment via the IEC 61850 system configuration language and other related methods. This way, we can describe the components and connections of the system, but not yet what it does. To this end, there exists the use case, which defines the functions of the system. It can also define requirements such as performance indicators that the technology should be measured on. Related is the standards IEC 622-559, which defines the use case template, and very much related is also the smart grid architecture model, which outlines how to orient in that space of potential smart grid functions. Now, this defines the technology, but how do we test it? To this end, we have to define a test case where we define what we want to find out, the purpose of investigation. We need to define the inputs of the test. We need to find the targets or test criteria. We also should handle a configuration of the specific test and also measure and assess the quality of experiments, consider uncertainty and errors. All of these aspects are quite orthogonal to the previous items, but they have to build on top of it. So there is some complexity here, and therefore we would propose the air-grid holistic test description. One would like to use this test description approach in principle just to facilitate a conversation for test planning, but it's very useful to manage integrated hardware and software testing on advanced testbeds, test systems that combine multiple domains, and to systematically design, test, and integrate results. Finally, this test description will also help to achieve reproducibility for complex test setups. Let's look into the essentials. What does holistic test description mean? How do we approach it? The core concepts is that the test description process comprises a set of templates called test case, test specification, and experiment specification, each offering a different layer into the testing, offering more details on a specific test. The test case provides more abstract conditions and the motivations for the test. The test specification clarifies the exact configurations of what should be tested, and the experiment specification then describes the actual lab setup. So notably, the test case does not describe the lab setup at all. It motivates the test, and then when we go to the test specification, we still have more details to clarify before we can actually define the experiment setup. Together, these three templates, once filled out, can offer a very detailed documentation of a test. When the test campaign is a little more complex, we can add a formulation of the qualification strategy, which supports the breaking down of a bigger test case into subtests. And similarly, if some of the tests should be done in different research infrastructures, we can offer an RI mapping strategy. To keep it more straightforward, what are the concepts that we then need to answer in a test case? This can be broken down into some key questions. First, why are we testing? And what are we testing for? Secondly, what is being tested? Thirdly, what is the context in which this thing is tested? And finally, how shall we quantify the test outcomes? So those are the main components of a test case. And behind these questions are a few more detailed concepts, which I would like to introduce in the following. So we'll see these questions raised before in the following, each with examples on this use case we've introduced previously. So let us begin. Why to test? The main objective is best described in a narrative. Similar to a use case narrative, we also can describe a test case narrative, which then can be broken down into specific purposes of investigation, which each describe whether the test is about, for example, verification or validation or characterization. These are three stereotypical types of tests that can be broken down, and they will lead to different methods of testing. So it's good to find in terms of words already early on what the objectives are here. So that's what we define as purpose of investigation. Later on, this purpose of investigation will be broken down into test criteria. Next is what to test. Here we define two types of concepts. That is the system under test, being the context that should be represented in a lab setup, and the object under investigation. So in other contexts, it's also called the device under test. So what is the thing that we are testing? It could be a piece of code, like a voltage controller, but it could also be a device, like a converter or a battery storage system. Finally, we also have the concept of the domain under investigation, which helps us identify the phenomena that are relevant to the test. So we're looking only at the electrical domain, or we're also interested in variability in the communication domain, for example. Since the system describes only the configuration, we should also define the functions. Functions are generally described in use cases, which are associated with the system. So, for example, in the case here, we talk about the optimization in a controller and the state estimation. These are the two components, functions performed by the controller, that are being investigated. So these are the FUIs. However, in order to perform such a test, we need other functionalities to be represented in the laboratory. For example, the DRPQ control, the tap changing control, and also measurements. That describes the functions under test. Now we know what to test. Lastly, we're looking into what to test for. Here we have to define the test criteria as the last part of the test case. These are a refinement of the earlier mentioned test objective and purpose of investigation, and they should refer to specific POIs. We are actually suggesting to break down the test criteria into target metrics, so the actual measure of performance of a test, variability attributes, we could also call that variability factors or uncontrollable parameters, things that disturb the test or make perturbations that will enlighten the test results. And finally, the quality attributes. So these are properties that we can assess about the test quality. Depending on what type of POI we have, especially the quality attributes will be of a different nature. For example, if we have a characterization test where we want to find out a value of a metric, then the quality attribute could be defined in terms of the remaining uncertainty of that metric. In contrast, if we have a verification type of test, then the target metrics and variability attributes are interpreted as a clear cutoff criteria. So the quality attribute will define exactly at which threshold a test is valid. So these test criteria are an outcome where we have taken a general discussion on the purpose of a test to a rather specific formulation, still in words, on what metrics we're interested in a test. This discussion, of course, needs to be continued to define the numerical and quantitative way of defining these metrics, and that is continued in the test specification. So now we have defined the first three items. Going further, we would like to know how to test. Of course, how to test is a more complex methodological issue. So all we can say from a perspective of the holistic test description method, that we are supporting the process. We have defined the test case, which defines the purpose of testing in quite some detail. The qualification strategy is part of the how to test, or how we break down the testing. The test specifications give us more refinement on what exactly needs to be tested, or in each subtest. So there can be multiple sub-test specifications for each holistic test case. And we have the experiment specifications, of which, again, there can be multiple experiment specifications for each test specification. So that is what this diagram is trying to illustrate, that in principle we allow a hierarchical breaking up of an original test case into multiple subtests. That's part of the concept, but it's not critical part. You can also address the holistic test description in a simple way with one test case, one test specification, and a single experiment specification. So if we look at this in terms of the templates and in terms of layers, we can talk about the holistic test case basically combining some use cases for the technology with specific test objectives. And on a system configuration level, we can say that it's rather generic. Tells us the scope of the types of technology, and it defines some fundamental system boundary at a conceptual level. The test specification gives us a more specific instance of this generic context and defines the specific numeric and parametric settings that should be used for the technology under test, and also of the system under test. How exactly should it be configured? The experiment specification then provides a concrete lab instance of that configuration. In this illustration on the right, we see the gray bar in the top being the system under test as a scope, being mapped to a distribution network and some controllers in the specific test system configuration. And in the bottom, we see that the configuration that is outlined in a specific test system is mapped into a simulation model, here in this case in a real-time simulator. And the controller, which was the OUI in the top level, is brought in here as a physical device that is interacting in a controller hardware in the loop setup. So this gives us an understanding of the layering and how we go from an abstract concept to a very concrete implementation that can be documented with the holistic test description. And since we have these concepts clear, we can now go ahead and fill in for a specific test case, the test case template. For test specification, we have a test specification template. And for the experiment specification, we have an experiment specification template. So to summarize this, the holistic test description has been developed for smart energy systems testing as a comprehensive test description approach. It's based on 3 layers of specification and templates called test case, test specification, experiment specification. The test scoping process can be further supported by intermediate steps called qualification strategy and RI mapping. And the core concepts have been introduced, which are the objectives, the purpose of investigation, and test criteria. And in terms of what to test, we have the function and object under investigations, the FUI and OUI. And in what context should be tested, we can talk about the system under test and the functions under test. The test specification, experiment specification are then detailing the how to test part. To test your understanding, we're offering here a quick self-test. So please pause the video. In the self-test, you should classify the information provided by these stereotypical titles used here. You should choose whether this is a test case, a use case, or a system component description that you would find under this title. Pause the video now. In the solution, we can see the first question is clearly a test case because it starts with validation and also sets the scope. We have on the right-hand side, the second case is a use case because it defines the action and the function performed by a system and also the system and stakeholders that create the value for. In the lower right side, we have a system component because no action is defined. It's not a test action. It's not a function that's being described, but we do have a structure in the form of noun. So we have the aggregator as a system and the distribution network as a system and their relationship. In the lower left corner, we don't have any of the three types of things. It is unclear whether it is a system is meant, a use case or a test case is meant, or something else entirely. To get started with the holistic test description, we have a strong suggestion to use the test case canvas, which is the backdrop of these questions here. You can find it as a PDF and really use it to kickstart your test case discussions. Just try it out. So it has several fields that are exactly the same fields as in the complex test case canvas, but it's useful to print it out on a big page and just scrabble together whatever you can find out. There's no reason to make a specific sequence of filling out the information. Rather, you should fill out those questions that you can answer. That's the best approach. Then we have some reference material. First of all the material is available on GitHub, and you should use the link provided here to get the resources and templates that you need for your purposes. You will also find guidelines and many further examples there. There's also a detailed method description available in a paper referenced here under A. So to summarize, you should use holistic test description if you want to facilitate a test planning conversation, and you can use it to manage integrated hardware and software testing on advanced test beds to handle the complexity arising there. You can use it for test systems that combine multiple domains simply because it facilitates the discussion in a structured way and it offers the tool for capturing aspects from different domains. Then together it helps to systematically design tests and then also integrate the results. Since we have the documentation and we establish the relationships between the different test elements. And all in all, this will help to achieve reproducibility for complex test setups.